And you did it. You hooked up a WebSocket to your very own domain name. Now, gemstack.lol is real time. It's live. We can all enjoy it for the power of the WebSocket and a little bit of Nginx tuning. And if you got stuck somewhere along the way, there were a lot of steps in that. It's really easy to go a bit awry. The link to the WebSocket example is in the slides. It's in the GitHub repo. It's all fully fleshed out and tested. It does work. So if you're stuck, just go in there and make a copy or find out where you maybe missed a line there. So let's move on and let's talk about databases. Why do databases exist? Why don't we just save everything to a file? Databases seem like a lot of work for what reason? Why can't we just save everything to a file?
They're unorganized.
Unorganized, yeah.
Inefficient to analyze that data, access the data across multiple files.
Yeah, it's inefficient. You can't really access the data across multiple files. What else?
Like the structuring of it allows you to go directly to like a relevant thing, while if it were just a normal file, you might have to read the entire thing.
I like that. Yeah, databases give you structure versus a file, which can be unstructured. Yeah, these are all good answers. We use databases because, one, a file doesn't scale. How are you going to have multiple servers writing to one file? Because a file can only exist on one hard disk at a time. So we could save everything to a file today, but if we had two servers, it's not going to work anymore. It breaks down. The other one is about structure. How do you save things to a file? What if my opinion about the structure of saving data to a file is different from your opinion? There's no enforcement there, so that kind of makes the whole thing useless. We called this out earlier when we talked about the modern computing stack, but everything you're going to do, this is my favorite quote from my CS professor, is he said, Gem, and he said this right before I graduated, he's like, Gem, 90% of the stuff you're going to be doing in your career is reading and writing from a database. That's it. And it's funny, but you think about what you do in your day-to-day. What do you actually do? At the core of what you're doing, you're reading from some API and probably writing from some API. Those APIs are reading and writing from maybe another system or service or maybe another database. And that's why in the modern computing stack, the database is always there, because we're never just reading and writing to the hard disk, because that doesn't scale very well. In the realm of databases, there's two different kinds. There's relational databases. So relational databases are MySQL, SQLite, Postgres, SQL Server, etc. There's even a browser database called index.db. A lot of people don't know that. There's a database built into your browser that you can use. It's kind of a pain, but databases are generally kind of a pain. That's why we have libraries on top of them. So relational databases are very structured. They're very strict. They have strong opinions about how and where you write and retrieve data. And this is good. The other kind of database is non-relational databases. So non-relational databases also have a structure, but it's a lot looser. And these are commonly known as NoSQL databases, which is, I don't know. You're still using some sort of query language no matter what you're doing. But the benefits of relational versus non-relational, relational is kind of like, it's like type systems. Like you can write your JavaScript code in just pure plain JavaScript, or you can write with TypeScript. There's pros and cons to both. If you use typings, it's going to be a lot stricter, it's going to throw up a lot more errors, and it won't let you do all the things you want to do. And sometimes that's a good thing. That's the same thing about relational databases. They're very strict, and you have to do things a certain way. Whereas non-relational databases, much more free. You can just dump things into them and query them back out. And there's pros and cons of both. NoSQL tends to be a little bit faster because there's not a whole structure that has to run through every time you make a query. But again, you don't have the structure. So that's a pro and a con. Today we're going to be using mostly we're going to be using a relational database, because that's probably the one that trips up people the most when they see the syntax of SQL. And a relational database is made up of, we'll say, two different parts. They're made up of, well, three different parts, really. They're made up of tables. So there's always tables of data. In this case, it'd be called the users table. Those tables have fields. Fields are also known as columns. So think tabular data, it's a column. Those columns have rows, or they're also called records here. And you're like, oh, that's great. That's a table. There's some rows. There's some columns. I've seen a table before, Jem. How does this all make sense? Well, when we have multiple tables of data, we have to get them to relate to each other somehow, hence the relational database part. In this case, user ID is known as your primary ID, or primary key. Every single table has a primary key. The primary key is usually an incremented number or some random hash. It doesn't really matter, but it's unique to that row in that table, and we can query against it very quickly. Now, if you want to have a primary key in another table, that's known as the, anybody take SQL here?
Secondary key?
Close, secondary key, you'd think that, foreign key. So a primary key in a different database or a different table is just called the foreign key. And again, we can query off that again. If we see in our food table, how it relates to the user table is that the food has some sort of ID. And that says like, oh, my favorite food is ramen, which it is. The type of ramen, I'm a fan of tonkatsu. Is tonkatsu spicy? Not generally. But that's an entirely different table. It's a table of everybody's favorite foods, but it doesn't tell you anything about whose it is. Is it mine? Is it Kyle's? Whose is it? We can use the user ID as the foreign key, and we jump back to the user table, and that will tell us the name, where we're at, the location, the email. So hopefully you're seeing like the power of relational databases where you have a bunch of table of kind of disjointed data, but you make it all tie together so that when we write a query, and we can write a complex query, we can pull a lot of information together using SQL, which is structured query language. So if I want to select just all the information about myself from the users table, I would say select star. Star is just the wildcard for everything from users tables where the name equals Jem. Probably the easiest example of SQL we'll write. Usually things get a lot more complicated because we want information from multiple tables of data, but we want to tie them all together. So we use something called a join. There's different types of joins. I will not go into joins. It's a whole thing. There's people here laughing because you've probably dealt with SQL joins at some point, and it's a pain in the butt unless you do it every single day. But here's an example of join where I was talking about ramen. I want to find all the different users and the type of food from the food table where the food name is ramen. So we have to left join the two tables together, the food and the users data. And then once we get the output, we can get data from different types of, we get the data from two different tables, we put it together, and it looks like just one big column of data. So you take this concept of relational database and blow it up even more, you see you can make some really, really complex queries, but at the core, the data you're saving and reading and writing is actually pretty simple. The tables are very structured. And there is, of course, an entire course on Front-End Masters on databases if you want to go really, really deep. But I bring up SQL and relational databases because a lot of front engineers get stuck on SQL because they're like, what does this mean? I don't understand what's going on. And really, if you understand table structures, you kind of get a better sense of how to actually query data.